Okay, example number 3 says a pilot's flight plan has her leaving San Francisco International Airport and flying a Boeing 727 west 5 degrees north. So be careful with that. It's kind of flipped it around. We're used to north-south coming first, but we start with whatever comes first. Okay. There's a 65 mile per hour wind blowing at an angle of north 60 degrees east. Find the direction angle that the plane is actually flying on and determine the airplane's ground speed. That's the speed relative to the ground. So it's not it's not the speed that's given right here, assuming that its speed with no wind is 450 miles per hour. Okay, that's a different measurement. Okay, we want to find how is this wind affecting its speed. Okay, so let's break down the two forces here are the wind and the speed of the plane. Okay, the two forces are the wind and the speed of the plane. So again, let's draw a picture so we can get a visual. The plane is west 5 degrees north. So we start at west and we go 5 degrees towards north. So we got 5 degrees right here. West, 5 degrees towards north. The wind is blowing at an angle of north 60 degrees east. So wind north 60 degrees towards east. And the plane is 450 miles per hour. The wind is 65 miles per hour. Okay, so let's break it down into their components. We've got everything we need. Now we can break it down into their components. So let's start with the plane. Okay, the plane, the x component is 450 times the cosine of 5 degrees made with the positive x-axis, 175. Okay, positive x-axis, not just any x-axis, it has to be with the positive x-axis. Just a little, it's okay. Okay. So y would be 450 sine of 175. Can somebody give me those numbers, please? 0.3. Okay. Okay. So before we move on, check and make sure that these make sense. The x is negative. We are in the second quadrant. X is supposed to be negative. Y is supposed to be positive. If you used 5, you would have gotten the same numbers, but both of them would have been positive. Okay, you would have gotten the same numbers, but the x would have been positive instead of being negative. Okay, so always check yourself as you go along. Let's do the wind. The x component is 65 cosine of 30. The y is 65 sine of 30. Okay, because 60 degrees is formed with the vertical. We need it with the positive x-axis. So 30. So can somebody give me those numbers?
X is 56.3.
56.3, okay.
Y is 32.5.
2.5. Thank you. That does not look like a 2. All right. So we put them together. The resultant, I'm going to draw a line, actually, to help me remember that once I put them together, I don't use the stuff above there. So the resultant, add the x's, 56.3 plus negative 448.3 and 32.5 plus 39.2. Can someone give me those results?
92.
392?
Yeah.
Okay. 71.7. Thank you. All right. Check and make sure where you're at. Okay. Negative x, positive y means we're in the second quadrant. Okay. We're in the same quadrant that the plane was originally in because the wind doesn't have, it has some force. It's blowing it some towards north, but not enough to completely shift it into the first quadrant there. Okay. So when we find our angle here in a second, we got to put it in the second quadrant. All right. So let's find the actual speed. That is the square root of the components squared. Do me a favor. Just don't put the negative in there when you square it. Don't put the negative in there when you square it, because then you don't have to worry about parentheses at all. Okay? Does anybody have that number already? Hmm?
98.5.
I forgot the decimal.
There we go. It's like, that's a really big number. Okay. We're good. 398.5 miles per hour is its approximate ground speed. It's slowing it down. Okay? It's taking it from 450 miles an hour to just under 400 miles per hour because of the effect of that wind blowing against it. All right? Then for the angle, that's the inverse tangent of the y over the x. So what does the calculator tell us? Negative 10.3. Okay, that is not in the second quadrant. That's in the fourth quadrant. So make it a reference angle. So we add 180 to it. So our actual answer should be what? 169.7? Okay. So it's still in the second quadrant. It's just not quite as close to flying directly west as it was before. Before it was only 5 degrees away. Now it's 10.3 degrees away from going completely west. Okay. We're starting to get the hang of this a little bit. All right. Let's do another one like this. Okay, do another one like this. Example 4. This time we have a ship that is sailing due south at a speed of 22 miles per hour. The current is flowing south 8 degrees east at 4 miles per hour. What's the actual speed and bearing of the ship? So our ship is going due south. I'm going to use green for the ship. Due south, straight down, 22 miles per hour. The current is south 8 degrees east. So it's this way. That's 8 degrees right there. And it's 4 miles per hour. So let's break this down. Let's do the current first. For cosine, what angle? Do what? Negative 82 or 278. Either one. Those are the same. All right. What do those components end up being? Yes. 0.6. Negative 3 point. Well, let's do 0.96. Okay. Let's do that so we don't round it to a whole number. Okay. Now, how about the ship? What's its x component? 0. It's not going anywhere to the left or the right. Its x component is 0. Its y component is negative 22. Everything is in its y component. Okay, nothing. It has nothing horizontal. It's going completely vertical, but it's going down, so it's negative 22. Now, I'm not saying you can't do the trick. Okay, you can do the calculation just like we've been doing using what, 270 or negative 90, but that's what it's going to give you. Okay, yes, sir.
So this one directly east would be 22 on the X.
Yes, yes. Okay, he said if it's going directly east, yes, the 22 would be in the X and the Y would be 0. Okay, so when we put these together, we get, let's see here, add the X's together, we get 0.6. Add the Y's together, we get negative 25.96. So the speed, I'm just not writing out the work this time. Square root of the X component squared plus the Y component squared. So 0.6 squared plus 25.96 squared. Don't put the negative in there unless you put parentheses around it. So it's just better that you not put the negative in there. So we get 25.967. It increased its speed. Why did it increase its speed? In the previous example, it decreased the speed. Okay, it's not really because of the quadrant. It's behind it. It's working with it. Okay, they're both south. The one's just going a little bit east, but they're both going towards south. In the previous example, one of them was going towards west and the wind was going towards north. It was working against it. So here they're working together, so the speed is going to increase. Let's find the angle. Inverse tangent, y over x. Okay, so we get negative 88. We can use that for the direction angle. That's fine because that's in the third quadrant. But let's look at what it actually says. It doesn't ask for the direction angle. It wants the bearing. Okay, it wants the bearing. So how can we put that in bearing form? If I start, let me get you started on it. If I start with the direction of south, bearings are always between 0 and 90. Yep. Okay, south 1.3 degrees east. Okay, I've worked backwards from the way I was going before. If my angle from the positive x-axis is negative 88.7, I want to know what's the angle from south. So I got 1.3 degrees there left towards east. Okay? So this is the direction angle. Negative 88.7 is the direction angle, but south 1.3 degrees east is the bearing. Okay, that's just a vocabulary thing you need to pay attention to. Direction, angle, bearing. This problem actually asked for the bearing. All right.